Oops. Welk geval is het? Hm? Hm. quite a lot. The end. Yay. Jab, choo, choo, choo. Shall I add a concept here or not? T here is in principle the element, so element compare must work on T. So we have something like requires. I forgot the syntax, man. Come on, this is C++ 20. Also new for me. But eventually I think something like it must compile if we have I would call this, so that would be an element, right? Let's say element 1, comma element 2, which I then declare here. Doesn't seem like I ever used that before. As it requires here, but it's just a Boolean expression. There's an example with code. So they make it as sort of a function. And yeah, this is a concept, however. I'm not sure if that is different. Let's see if we can find other examples. Well, who would have guessed that? Requires. Really. No, I missed it. There it is. If you want to allow any type T for which operation a plus 1 is supported, you can use the requires clause with the requires expression as follows. Yeah, but I think it was here. Or not. I forgot where I was. What the hell? In utils. This is in utils, but well, that's where we were. Give me a second to turn on the light. Otherwise you can't see my keyboard. Yeah, sometimes I still need to see my keyboard. Well, I think this works, so now it's refusing to accept this unless element compare for T exists. I might give a nicer compile error. And that's really the only thing we use because, yeah, this is an iterator of the vectors, so the reference gives us this T. So it's definitely a T that we are using here. And then in the pair compare, could do the same thing, I guess, but it is more complex. Maybe it doesn't have to be that complex. I mean, I chose to use if const expression, although it's, yeah, maybe silly. So what this what if const expression does is that you just get that this is Boolean is evaluated during compile time, and then it generates this code, or it generates the else clause code, which means you just get multiple functions depending on the template arguments and then whatever the result of this call is. However, that then in turn is actually the same as just having an overloaded operator, I think, where first and second is or are not a vector. And if I do that, then I'm basically going to do here the exact same as is specialization is doing. So I will not is specialization anymore, but I would make 4 functions, but the code doesn't really grow because there are just all these different chunks, I think. And I think it's more logical to use function overloading than to use the if const expression in this case. So let's do that. That means that this thing here also I'm going to have, let me be more clear then, you have this, and then say we start with vectors. So I'm gonna make this a vector. Oops, standard vector. And this the second type must be the same, or at least it is going to be the same when the way I use it. I think I'm just using it with standard less, the standard less in a standard map. No, I'm replacing the standard less with this, so just a compare function. But anyway, it's going to use the same type here. Right, so that would be one, and that would be the one where both are vectors, so there's this one. You can just copy that and then put that here, right? And it proves more or less that it is better readable, because I do not have to add this comment anymore. It's pretty damn clear that both are vectors. I do need my vector compare first, which is declared here. So let's copy that over there. Now, might be a problem if first itself is a vector, but that's not the way I'm using it. On the other hand, this is in utils, so it's very general. Should be usable very general. If first and or second in this case is a vector, so really we have a pair of a vector of vectors, then things are going to break down. Because no, it's not even going to it's even then it's working. Then just first compare and second compare must be a utils vector compare of the element compare. So even that works. Right, well, let's start with a vector for first. and not a vector for second. That's this one, only first is a vector. Where's my vector compare here? Doesn't look right. Let me first copy all the code and then fix it, because I don't think that's correct. Only second is a vector, and then we have neither. Okay, so let's do that. Let's be lazy and start with this. And then even more lazy and copy it again. And then copy the code, so we're not using the is specialization anymore. And we're left with only second is a vector, which I'm going to put there. Okay, let me fix it then first. Standard vector and standard vector. And neither is a vector. Well, you have to admit that this looks better than with the if const expression. More or less simplified, I think. Well, I'm going to start at the bottom. If they are not vectors, then I'm just comparing them directly. Left hand side less than first, then it's true. If a right hand side is less than the left hand side, then it's false. Otherwise they are equal, and I'm returning if the left hand side second is less than the right hand side. That sounds completely correct. And the top one is correct too. Now they are both vectors, so I use the vector compare utility. And then it's basically the same thing. It's the left hand side less than the first, and right hand side is true. The right hand side less than the left hand side first, it's false. Otherwise they are equal, and we return whatever the result is of the compare of second. However, for some reason I'm being an idiot here. No, what am I doing? If left hand side, okay, if left hand side second is less than the right hand side second, then we return true. If that's not the case, then either the right hand side is less or they're equal. In both cases, left hand side is not less than the right hand side, so I must return false. So yes, I'm being an idiot here. Not just an idiot, it's even wrong. Why would I return here right hand side first, right hand side comma left hand side? It's just nonsense. This looks better. Left hand side, we return only true if the left hand side less than the right hand side. First we compare first. If it's the other way around, then it's false, and otherwise they are equal. The first is equal, so we compare second. Yep, much better. Doesn't really matter where you put it, but it's pretty much convention to put this close to where you use it, even though those compare things are empty. So they don't even they don't have a constructor and they don't take space on the stack. So in that sense, assembly code doesn't change, but certainly wouldn't after optimization, of course. Okay, so this one was broken in my eyes because first is a vector. I'm not using vector compare here. So you're definitely going to need that. And then as far as I can see it, what the hell is this? Oh, size. Yeah, right. There are vectors. So I'm comparing here. Oh, wait a minute. No, I was not that stupid. If the right hand, sorry, if no, this is second is not a vector. Yeah, no, I was stupid, and not a little bit. Holy moly, what a nonsense. What the? Quickly erase it. Just copy this part. First we compare the vector first. And if that is equal, then we just compare the left hand side second with the right hand side second, which is not a vector. Exactly the way it's done here. And then this one is also nonsense. So that will be a copy of this, followed by this, I guess. No, now we do have code duplication, unfortunately. So now I could make it what it was and then use the if const expression again. But yeah, I kind of like it this way. Despite the code duplication, it's better readable. Okay, does this make sense now? So if the left hand side first is less than the right hand side first, then it's true. Other way around, it's false. Otherwise, first is equal, so we compare second. Looks good. Yeah, well, that was broken. No, it isn't, I think. Right. I feel like removing the specialization now, because I'm not even using it. I didn't write it. Why did it not say that? Show that? Well, whatever. Git status. Yeah, I'm not adding it. Remove. Did I have a look at this file? Suddenly cannot remember that. I guess I did. Yeah, it's not really used. Another thing that is not really used. Okay, let's remove these things just to have it something clean. Okay, utils, although that's also automatic, I think. If I do git commit -a, and then what do we do? Work in progress. Yeah, totally work in progress. On what? Yeah, still declaration. GLSL declaration generation. Push it. And the commit has been done. Then we'll have to continue with the generation of the declarations, right? Let's see how many things this still needs to be. How many declarations still need to be generated in this one? I think we got around. So apparently there's no fix me in the GLSL code. I have a vertex shader here with an output, and there we have and two other outputs. So I'm only generating declaration for inputs, so this is already totally generated. Yeah, that's correct. Push constants and vertex attributes are generated. But textures are not. I think these two should be generated. So what does actually fix me missing here? Well, these are the inputs of the previous outputs, and this is the, and again the output of the fragment shader. So I could start here with these two things that they have to be generated. They are the uniform sampler, what is it? Image combination. Okay, so how is my program going to know that it has to generate this? Well, it knows that because I am using this string here. So this U texture background, I'm using this string. And then it's going to generate this line. So not still hard-coded, but in the end I'm just going to add this line, and then it's generating that line. That's the idea. So we have here texture background and texture benchmark. Now it can see that it has to do something because there is a double colon here, and a double colon doesn't compile in GLSL. But how does it know what to do? It encounters this. I could look for double colons and I say, ooh, there's something here I need to do something with. But what? Well, that works because the C++ code is simply adding this key. But not directly. Not directly, but then if it's not adding directly, then it should be adding it by string as a background, right? Just background. Now we are around, so apparently not. Maybe not here. Let me exit this. It should do that. But it isn't, apparently. I remember vaguely to already have written something in that direction. Maybe I wrote that for the other one, and of course I cannot remember anything, so let's have a look in this file and then maybe find that back, and then I can remember again what I was doing. So TLSL, here we have also fix me, this should be generated stuff, but let's go with the texture, which is in the fragment shader. Out, put what? This is not a vector, vertex shader. Here is the fragment shader, and it says fix me, this should be generated, and that is a texture. And that would be generated from nothing. It's not even mentioned here. Nope. That's not how it works. Apparently I did not write any provisions for this yet. I was also very sure that I wrote a texture.h file, which is now not here. I think I changed my mind. For the uniform buffers, I have this kind of files where I just define what it is with these two things. For some reason I didn't think that was the right approach for the textures. Okay then, if there's no begin here with that, then I might as well go back to the other one. Okay, so we're at the fix me again. This should be generated. How does it know that? Well, because I have this string here, this string, and then I need to add that string from the C++ code. Poo-poo. Okay, well, no way that I'm using a different string than this for the texture. Although it used to be called sample, I think, in the C++ code and benchmark in GLSL. But I think I renamed it. No, I didn't. It just jumps back. Holy moly. Okay, sample. Sampler. Sampler texture. Sample texture. There it is. Sample texture. So instead of sample, I should use benchmark, so at least those things have the same name. I don't think that sampler is the same thing, but sample is probably the same thing all the way around. Well, we have also sample parameters. Sample being the application, the test application. Yeah, totally different things. It's really just a sample texture then. Sample without texture behind it is probably not a texture then. So I'm gonna look for a sample texture. You know what? I'm going to look for ample texture with the capital T. It doesn't exist. Ample underscore texture. It's always going to be sample texture. Start at the top. This one should be benchmark, 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 benchmark. Are we back at the top, or where are we now? Oh, here. Because this window owns the texture, okay. and again, and around, I guess. So substitute in the whole file. I think it was always msam texture with benchmark texture. Hello, Krishna. What is this? An error, an error, an error. Hey, the requires does not work. Template, function name, requires. Does not declare anything, but still. This is for a template function. I did put it behind the template. That's probably what is wrong here. Should be indented. Let's try that one. Nope, doesn't want to. I'm going to try without the bool, although I don't think that does matter a lot. Oh, it could be that it doesn't know what this is. I'm just using something. Let's try to construct a temporary here. Might as well leave my bool in. Annoying when there's two bugs. You find one and then it still does not compile. And now we're going to find a third bug, which namely, okay, I'm gonna remove the bool because I want to make sure that that's not a problem. Again, there was another one. I was looking, but I didn't see it. I think it was not on my screen then. Oops, we cannot print SetLayout. In instantiation of function template specialization requested here. Yep, okay, we're printing SetLayout here. Well, we are printing this thing, which is a vector of SetLayouts. And I have debug functions that say, well, if you want to print something and it is a standard vector, that I'm going to print a list of whatever it contains, but it doesn't know how to print the elements. So we have to add that as well. And I have a trick. Now normally will print means writing to an O stream with left shift operator. But I didn't like that, because then you have to make it a friend, and then you have to repeat everything all the time. I'll give you an example. What you should do is friend standard OStream reference operator less than standard OStream reference OS, comma, the thing that you want to print, const reference, well, X, but no, it has a real name, makes the thing a lot more annoying. And then you have to return OS, and then here you have to write stuff to OS, for example, the first one and the second one, okay? I'm only typing this in for you guys. The problem with this is that I had to repeat SetLayout twice. Can you imagine how that looks when you have 20 members? Horrible. So and I have to add a stupid friend here. So what I did is we're not doing this, we're not doing this, we're not doing this, we're not doing this. Actually, we do nothing. We just avoid print on. Oh no, that's not true. Okay, we do not this. I keep the standard OStream. I do void print on standard OStream. It's not a friend, it's just a const member function, which has direct access to the members. So now I can remove these things. And I don't have to return OS. However, print on is nice that I have a member function here, but that's not giving us our OStream left shift operator, of course. Or is it? And yeah, the trick is it is, because of other provisions. I'm going to implement this, however. It's a struct, so we start with a brace open. And we end with a brace close. And then I want to print the name of all the elements. mhandle, well, why not? mhandle. Another convention I have is that for this debug output, I have no space behind the colon. Call me weird. And this then is going to happen, work, because I can print vectors, as we have seen before. Not sure though if, well, we can only do that for debug output, and this is definitely only debug output. So this is CW debug code. I'm not sure if I have to drag something in to get my vector stuff, but why not add debug, right? So debug.h. I should drag in a lot of stuff that's for debugging, and I think also allows me to print vectors in this way. And Squoff types, I am currently learning the basics of C++. You're on a Grandmaster channel. Well, most people that are watching me are beginners, I have to feel. At least everyone who says something in the chat. Kind of funny, actually. What recommendation do you have as to create? I should write a how-to. I already answered it a few days ago. Let's see if we can summarize it. Yeah, what I said was go to learncpp.com and then do one chapter every 3 days by reading diagonally over it and concentrating mostly on writing applications in which you test what you just learned in that chapter. Play with it, test things out, but you have the whole site done in 3 months. It doesn't really matter how much you learn, basically, just no more time than 3 months. And after that, you know the syntax, you know you have written a lot of things, so that will stick in your memory. So then later you need something, you can look at the programs that you wrote, and because you will remember those, and you will not remember the website or where to find it. And then there is cppreference.com for, you know, if you want to know, okay, there is a standard map, but how did it work? Then you just look at cppreference.com. And that, what together with Google, that's the only sites you need. And then specifically recommendations for what to create. Yeah, well, anything that motivates you to work on it. I started coding when I was 12, and the first program I wrote was something that printed all the prime numbers till I think 250, because it was in BASIC and the largest array was 256 large. Okay, I have to continue here. So I say I write this, and then the question is, do I have to include a header? And I did include debug.h, and I think that's gonna work. Now magically it's going to allow me to print this thing now to an O string, simply because I added this. And I have no clue where the magic is, so I cannot show you. Yeah, maybe I will. I mean, if people keep asking the same questions in the chat, then I should. And it's literally in FAQ. These days people call everything an FAQ, even if nobody ever asks a question. They just make up their own questions. Well, it did not work. What is the current problem? Here we have something, use of undeclared identifier and top descriptor set. Did you mean something else? No, I was thinking about it. Okay, that's at the very least confusing, but this must be a handle, that's correct. So maybe, yes, I did rename it to something with a vulkan handle in it. Right, it compiled. No errors. Don't think so. What did I change? Something with I forgot. Oh yeah, benchmark. I renamed it. Oh right, that was it. So I need to add somewhere the string that is used in the shader. The most logical place to do that would be in maybe I should commit this first, because the next step is definitely unrelated. So this is a rename. Add a comment and more renames. And here we have a fix basically. Commit. No, first look at the status. Utils is modified. I have to change that as well. I did commit it. Let me push it as well. So now it's clean, get push. I'm lazy. Work in progress. Okay, everything is clean again. And the directory where I was something like this one, I guess. Though it doesn't really matter that much. And if we look at window.h, here I'm mentioning the texture, right? How many places am I really mentioning that thing? Here I have a texture. Texture is stored in the window class and then filled in. Let's see which function this is. This is create textures. That makes sense. And then update the descriptor set. It is mentioned again to couple the descriptor set to the texture. Or the descriptor, I should say. Now somewhere I should say, I should tell this thing how I want to call it, this texture. In the shader. I could have the fact that this thing has as type vulkan texture is enough for me to say. Therefore, I call it texture in the shader, and then I need a name, right? And that name is, in this case, benchmark. Why not add that right here? I can't really think of a reason. Let's have a look at the constructor of texture. That I have to pass a logical device and how large it is and what kind of texture it is, or what I have to pass a sampler in this case. And then we have memory stuff. And that just says to do without the memory is allocated on the GPU, I think. Okay, yeah, and then we have another this constructor here, which creates a sampler. So here we pass a unique sampler, and here we just pass a sampler kind, and then the sampler is created. However, as you can see, this constructor simply calls the other constructor. That's a cute trick, isn't it? So this constructor is implemented in terms of the constructor at the top, and there is another one that also, and another. Oh no, that's default things. So you can ignore these for the moment. This is the only real constructor. And yeah, I just have to add a name here of that thing. Shall I pass it as a character const pointer or not? I probably have to do stuff with it and then, I mean, put it into a string. Because I think I'm always going to pass a string literal. Now, I used this before, GLSL ID string, but that's the full ID string. So that is the texture : benchmark string. And I only wanted to pass the benchmark part. I also somewhere have code that calls the texture prefix and the texture : string long prefix. So I guess I'm going to call this postfix. Pretty random. But the string is long enough that it's unique. So if I wanted to rename it later, it's going to be pretty easy to do that. I must say that normally I do not abbreviate anything. So this is a very serious exception or violation maybe. I think that even GLSL stands for something. One of the L's probably a language. ID is obviously identifier, and str stands for string. And I have no idea why I abbreviated those. But I started to use it, and now it's this thing is something by its own. I guess I'll stick to it. Otherwise, I'll have to rename it everywhere, and then it becomes pretty long again. The only really there's two reasons why abbreviations are bad. I think the worst one is when you forget them. So you cannot even grab for them. So do regular expression searches for them, because you don't know anymore what you used. And the second one is, of course, that if your strings are too short, that you get all kinds of hits. I switch my source 100 times a day, all the source code. So I really need unique names. If I could call this just G or something like that, yeah, no, you cannot say let's grab the source for G. It's not working. Now we have to store the thing, but not only that, I'm going to have to pass it to every constructor. And then we call the first constructor here, so I can just pass it on to the first constructor. And that one then will store it locally, I think. Memory image. Does my image have a name, or is it really just a texture? I guess it depends a bit on where I need it. If at some point I only have a pointer to the image, and then at that point I need a name, then I might move it. But let's for now assume that I just know that it is a texture, and I will have the texture the moment I need a name, because as far as I know, I am only going to work with combined texture samplers, and the rest is going to be something totally different. It's certainly not something derived from image. So it's either a texture or something completely different. So I might as well begin with putting it here. Now I'm going to store it as a string, because I'm going to immediately convert it to the full GLSL ID string. Why the hell is this public? Nah, I don't like that. So let's make it private and then see where things stop compiling. Anyway, we have here texture that. I need to initialize the thing now with, yeah, and then it's not that nice that it is a string literal. Maybe it should pass a string view instead. That would work. In the end, string views are better, right? I mean, they're definitely more modern. Let me start string view. String view is a pointer into a buffer, so that's the same thing as the character const pointer, but then it also has the length. So then your string does not need to be zero terminated. But the size of the string view is twice as large as a pointer. But definitely more flexible. I can pass in string literal to this now because it's by value, and also a string. However, converting the string view to a string that requires allocation of memory. So it's definitely kind of not efficient. And what I would want is a string which then I can immediately move into the MLSL ID string. Well, if I make a temporary here, and then it's an R value, so it's going to use the move constructor of the string, and so that's efficient. But I also would like to have immediately the right memory allocation. Although I'm probably micro-optimizing a little bit too much. Most definitely am. I'm just going to do this. I guess I can add the string views to strings. This looks a bit too much like a function. Compiler might get confused, so let's use those things. So I construct a temporary string, and then I can add stuff to it, and then we store that. We move that in our GLSL ID string. Nevertheless, I am just curious if there is not a constructor for standard string that allows me to immediately pass the amount of memory that it must reserve. I don't think that exists. No, it does not exist, I think. I think this string is small enough to not allocate anything even. So then we still get only a single allocation. Just storing this in line in the string and then adding this, and if then it gets too big for inline storage, it's going to calculate the size of this thing, which is also hard-coded. This is string literal, so it immediately puts the length of this string in the place of the member of standard string that contains the length of the string. The string view has a length as well, so it's just adding two integers and we have the amount of memory that we need. Does one allocation. Yeah, okay. I'm happy enough with the idea of this speed here. As if this needs fast. This does not need to be fast. What am I rambling? Okay, it compiles. Good. We have it? Yes. It's stored in texture. Vulkan texture. I need an accessor because I made it private up there. Let's add an accessor. Accessors, maybe. Standard string, const reference, the GLSL ID string. Okay. Do we have other things that we want to access here? Unique image view, yeah, probably, because now nobody can access it since I made it private. So I have image view and sampler. And I'm just going to return, I don't want to move it out, so just going to return the handle, I think. So I have an image view. Oh, wait. Now I have here the texture, and I have to pass a name. Let's do this benchmark. Yippee, compile errors. Always go to the top and look at the first error. It's even worth the 5% of my life that I'm scrolling up. Error, invalid operands to binary expression, standard string and string view, so you cannot add them. Moron, why not? Let's have a look at what we can add. Standard string. String view like, that's funny. Okay, that's weird. They have an append, but the plus operator is not overloaded. You can see me shake my head in surprise. And of course I forgot to copy the... Really? That one, okay. No matching constructor for initialization of vulkan blah blah blah. Yeah, we probably have multiple of those. This thing is called this thing is called nothing. That's part of the library. Upload texture, passing, unique pointer to a data feeder. Oh, sort of, I think this is the same as we just had, but now created from a data feeder instead of read from a file, something like that. So we don't know what texture it is, and the name has to be passed, I think, in to upload texture. So before I add that, let's make sure that is the case. So I'm just going to grab project sources for upload texture. Definition, debug, declaration, comments. Only called for IMG, from IMG. This is the font texture. Here's the fragment shader of IMG, and we're using set 0 binding 0 uniform sample blah 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 as texture. This thing is not pre-processed at all because I'm just starting it with hash version, and then it leaves the shader alone. This is so static. I did not want to make the IMG stuff generated. Well, actually, I am. Yeah, this one is. This one is not. Maybe I can do that in the future, and then I'll call it just font texture, I guess. The name is otherwise not even relevant. Meaning I am going to pass it. And we'll call it font texture. Character const pointer GLSL ID string postfix, and then we can pass that here. And then I have to fix the declaration. Add that as well to upload texture. Yep, I made that private. I guess we'll run into more of those. Maybe it would be nice to be able to run over all the places where something is being used. Someone told me, why are you not using an IDE? I guess he means Windows IDE stuff. I don't know if it exists for Linux, that you can, that your editor is really understanding the source code. Otherwise, you would never know where some variable is being used, right? You need a kind of a compiler to figure that out. Error, no matching constructor for initialization of vulkan texture. Uniform buffers. Sample texture. Pretty damn sure that in uniform buffers. Okay, yeah. That's just a texture. Well. Here I call it Vort3 texture. And it does say that it should be generated, so it better has a name. So let's call it Vort3. I think it's short for vortex, but in the end I just downloaded the texture from the internet and I think it was called Vort3 or something like that. I'm gonna keep it at that name. Vort3. Oh, this one here. Vort3. Okay. Yeah, how many others do I have? I don't know. I can try to find it in the source code, or I can just recompile and find everything that way. What is this? Sampler is a private member. Yeah, we expected more of those. So those have to be removed, and then we get here a function with the same name. I can't help it. It was on my screen. Okay, who doesn't want some music? I'm listening to music, but we could turn some music on. It's another private member. Okay, what are already doing again? Make. I suppose we are at 98%. I think it worked. It's got everything. Yeah, so now I added a name to all the textures. Very nice. Okay, let me put on some music for you guys. Everyone is cursing because they already have their own music probably. Pom 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 pom. Bottom, there it is. Lip. That's running. And that is also playing, I think. This goes into tune tank, yeah. Oh yes, to you guys. Yeah, okay, seems like that should work. Test. I hope it's not too loud. Yeah, how do I make any sense of this mess? So I want to turn off my own music. This pulse trends. Well, it's not really. Okay, so now I only have stuff here in the OBS monitor. I think my voice is loud enough over the music. Control F1. Okay, so yeah, let me turn the monitor off again. And that on again. It is very difficult, benchmark. So this object now contains my string. And that is here, the string is initialized. And here it is coupled to the descriptor. think I'm using it afterwards anymore. Nope. So probably this is the place where I also have to move the name that we just made to, let's say, the descriptor. Really? Yeah, so a big question mark at this point, what to do here. Now I can look from the other side, which is at the moment that the shaders are being pre-processed. Okay, alright, shader variable. It looks in all the shaders for the strings that it finds in shader variable. So I have to register my strings with M shader variables. I really try my best, my hardest to do everything exactly once in the code. I once worked on code base of Linden Lab. Almost, I feel the stomach acid in my mouth when I pronounce that name. Worst company ever. And they had I wanted to fix the HTTP and networking stuff. They literally had that 7 times in the code base. 7 times code duplication. What a nightmare. In my opinion, you can recognize a good coder by the fact that everything happens exactly once in one place. No code duplication whatsoever. There are exceptions, but that it better be in one file and super close to each other and not too much, and then still you have need to have a very good reason. In other words, if, I mean, I have to repeat, I don't have a good memory anymore at all. I don't have a memory at all anymore, it seems. But if I know myself, then those GLSLID strings are going to be registered exactly once and only once. This is the only place where they should be available. If I add them to this, they are hooked in. There cannot be another place that I have to add them. That would be stupid. That would be bad coding. So the question is, how do I add those things to this variable? Or where do I add them? Now, it is a vector with objects called a shader variable. Yeah, shader variables are stored somewhere apparently, and then this vector just contains pointers to that. So let's just have a look in the header file here where that is all used. It's mentioned in a comment. Add a shader variable. This is for push constants, and here for vertex attributes, I guess. Yep. add a pointer to the vertex attribute that was just added to mVertex attributes. Add vertex attribute. And here another add vertex attribute, but then for arrays. And then I have add vertex input binding. Something else. I think the push constants are above here. Nope. Well, they must be somewhere. Okay, so we call add vertex attribute for the vertex attributes on the shader input data. Which only happens in one place. That happens here in add vertex attribute binding. And that is being done here. So this is the user code. All the super complex template stuff you just saw, there's nothing to do with the user. Only I have to write it. The user just does this. It calls on shader input data add vertex input binding. Two things, and we have a push constant. Well, I have an idea. Shader input data add texture. Got what it was called. Benchmark texture. Yep. And background texture. Now you might think, yeah, what the fuck, I'm gonna have 10 million textures constantly changing. So how does this work? That you hard-code adding 2 textures. But it's exactly as hard-coded as shader, right? This is about, I think the music is actually too loud. At least in my ears, for me. Anyone has a problem with the volume of the music, say so in chat, and I'll move it down. Maybe I should do that anyway. Yep, and I forgot again which slider that was. Oh, this one, of course. A little bit softer, I don't know. Tell me in the chat. Yeah, Scorf asks, what exactly does a Vulkan engine do? A lot. I cannot explain that. Basically, it's a game engine. That sounds more familiar. Although a game engine is probably more, game engine also involves stuff like collision detection. This is just the graphics part of it. So I do have one fragment shader here, and that fragment shader is using 2 textures. That's where the 2 comes from, and that's why I have 2 lines here. The shaders also are hard-coded to use per vertex vertex attributes, and per instance vertex attributes, and a push constant. So this just, yeah, this defines my pipeline. There's nothing I can do about it. So I think it's super logical that I just add these two lines here. I have vertex input twice, and I have push constant, and I have two textures. And each of these lines is then going to result in the automatic generation of the declaration of the GLSL variables that are involved with it. Call me lazy, and I think that this is much easier to write than all those set is 3 and binding is 7 numbers, which you can mix up and need to be the same in 3 different places. That's basically my biggest motivation to do that. You can just give them a number, but you have to keep the numbers the same in several places. I did not like that. Then I have to write the add to texture function, of course. Okay. Putting it close to add push constant makes sense, I guess. Here's an add push constant. That's funny. I'm also the author of libcwd, even my initials in it, and that does all my debug output. And I have provisions for, say, printing the full demangled name of the type that is being used here as a template parameter. And I think people are catching up, because I wrote that 20 years ago. Definitely did not exist then. And yeah, maybe not the other libraries, or even I think recently they added something to the standard. Standard ABI has a demangler now. I can imagine that now you can do the same thing without my library, but that definitely was not the case in the past. And yeah, I just keep using my library anyway, and it works, and it is super fast. Extremely fast. Writing fast code is my middle name, right? I'm pretty sure that this whole thing compiles to a string literal. There's just some global static variable that contains this string. Okay, let's see. Entering that thing. Passing this texture. Oh, here you see an example of the ABI. That's what I meant So they have a, yeah, dip it. It's right here. That's how you can do it as well these days. Without my library, you can just take the type ID of the type, and then call name, and then call the ABCXX demangle on that. You get a demangle name as well. So that might be handy, especially when you're debugging templates. But I'm not sure if this is not a runtime function, or maybe it isn't. They have all these const expressions these days, const evaluations stuff. I guess it's also fast. Yawn. Yeah, what were we going to do? Well, we're going to do the same thing as up here, except this one is pretty difficult because it's iterating compile time over members of a tuple. We don't need that here, just have one texture. So this is a difficult construction with, I forgot the name, but there's a name for this thing here. Repeat stuff and lambdas, and then in the end it calls add push constant member for one of the tuple members. So that then we get here, and that does difficult stuff as well, and then in the end we get I guess this line here. Or is it that one? Probably both. No, this is a push constant, which is definitely not it. This is a declaration constant context, also not it. Well, someone must add it. I forgot what it was adding to. Well, shader variables, like M shader variables. M shader variables. Yay, it exists. What happens here? This is add vertex attribute. Well, let's look at that one then. Same thing. The function add vertex input binding is called, and then that calls multiple times add vertex attribute, which then in the end adds a shader variable. Which makes you wonder, well, a pointer to it, right? This thing contains pointers to shader variables. So it still has to, the shader variable itself still has to be added somewhere else. Apparently it's being added to vertex attributes, which is very specific to vertex attributes. In other words, vertex attributes, which contains vertex attributes, surprisingly, and then that is derived from shader variable. That was the trick. Yep, that is the trick. So it's part of shader builder. I need to make a new struct which is derived from shader variable and which represents a texture or a combined image sampler, whatever. Maybe I should call it that instead of texture at some point. Yeah, I think I'm going to stop right here. And continue tomorrow, okay? Let me just write a to-do here. So what we want to do was make a vector. So make a vector of shader builder combined image sampler derived from shader variable. Add an element to that here and a pointer to that to m shader variables, I guess. Yep, up there. Okay, good night. I'll continue tomorrow, no doubt. So I'll see you then maybe.